Hello friends, welcome to Quality Talks. I am glad to have you here. In today's video, we are diving deep into FMEA, Failure Mode Effect Analysis. This is a crucial tool in quality and risk management, widely used across industries to proactively identify and mitigate potential failure in a process, product or system. In this video, we will cover the concept and fundamental of FMEA. We will see how to evaluate and assign rating for severity, occurrence and detection. We will understand and calculate the risk priority number, and we will see how to use action priority for better decision making. And finally, we will walk through a real-time example using standard FMEA format. This video is designed to give you both theoretical understanding and practical insights that you can apply immediately in your quality work. So get ready to enhance your knowledge. Let's begin this journey together. FMEA is a step-by-step approach for identifying all possible failures in a design, a manufacturing or assembly process, or a product or service. As FMEA is a failure mode effect analysis, so failure mode is the ways or modes in which something might fail. Effect analysis is studying the consequences of those failures. When the FMEA is done for process, it is called Process Failure Mode Effect Analysis or PFMEA. When the FMEA is done for design, it is called Design Failure Mode Effect Analysis or DFMEA. Let's discuss the history of FMEA. FMEA came into existence in 1949 when US military uses the FMEA for their operations. In 1960, NASA adopted the FMEA for their missions. Around 1970, auto industry started using FMEA. In 1982, AIG published first FMEA manual for auto industry. And recently in 2019, FMEA manual is commonly published by VDA and AIG. As we discussed, FMEA is a tool for risk identification and risk mitigation. For risk identification, a risk priority number RPN is calculated or action priority is identified. So FMEA helps to quantify the risk. Through risk priority number or action priority, the risk is quantified. Risk mitigation is done by taking action to reduce the risk. RPN or action priority is calculated using the three quantifiable parameters: severity, occurrence and detection. Severity quantifies the effect of failure on the scale from 1 to 10. 1 is the least severity and 10 is the highest severity. Occurrence quantifies how many times failure has occurred in past. So it is based on the past data. Occurrence 10 means failure is almost inevitable. It means continuous failures are happening. Occurrence 1 means no chance of failure at all. Detection quantifies the capability to detect the occurrence of failure. Detection 10 means detection is almost impossible. It means you can't detect the occurrence of failure. Detection 1 means detection is almost certain. You can easily detect the occurrence of failure. RPN is calculated by multiplying the severity, occurrence and detection rating. Higher the RPN, higher the risk. In the case of RPN calculation, a threshold value of RPN is determined for identifying the action priorities. As per new AIG VDA FMEA manual, RPN is replaced by the action priority. As per new manual, prioritization is now based on table that is provided in the manual. This table considers severity occurrence detection holistically rather than a single numeric value. If the action priority is high, then it is mandatory to take action. If the action priority is medium, then one should take actions. If the action priority is low, then one could take action. Now, how to decide action priority? It's very simple. Let's take the case of severity 9 and 10. If your severity is 9 or 10 and your occurrence is 8 or 10, for any value of detection, your action priority is high. Similar is the case of occurrence value 6 to 7. But when it comes to severity 9 and 10, occurrence 4 or 5 and detection 1, then action priority is medium. And for the severity 9 and 10, occurrence 2 to 3 and detection 1 to 4, action priority is low. So based on different combination of severity, occurrence and detections, action priority is decided based on this table. As we discussed earlier, severity is the effect of failure. This effect of failure or error can be ranked based on the end user. It means customer that will use the product or service, or based on the next operation. It means next operation where the product will be used. We will discuss the case of automotive industry and will give severity ranking based on customer effect, it means end user effect, and manufacturing and assembly effect, it means next operation effect. First effect is failure to meet safety and or regulatory requirement. It means with respect to the end customer, safety is the concern and regulatory requirement is also a concern. Potential failure mode affects safe vehicle operation and or involves non-compliance with the government regulation. So vehicle meeting an accident is impacting safe vehicle operation. So take a case where brake fails. It means safe vehicle operation is impacted. Non-compliance with the regulation. Take a case, our vehicles in India now are with the BS6 emission compliance. So any failure which results in non-compliance with respect to the BS6 emission norms will fall in this category. So severity 10 affecting the safe vehicle operation and non-compliance with government regulation and without warning. So these two things are happening without warning, calls for severity ranking 10. We discussed brake fail will definitely come as an 10 ranking. Now severity 9 is same, just it's happening with warning. Like we discussed, if BS6 norm is being impacted, then any warning coming on cluster, then it is a severity 9. Now we will discuss severity 10 and 9 with respect to the next operation or manufacturing or assembly effect. May indulge operator without warning. It means any accident will happen with the operator without warning is severity 10 and with warning is severity 9. Now let's discuss severity 8 and 7. Severity 8 and 7 comes into one group, loss of degradation of primary function. So what is primary function? For a vehicle, the primary function is running. If vehicle is running, the primary function is being met. So what severity 8 calls for with respect to the customer? Loss of primary function. It means vehicle inoperable does not affect safe vehicle operation. It means vehicle is not running and it is not impacting safe vehicle operation. If it is impacting safe vehicle operation, then it will come in severity 10 and 9. But here loss of primary function is happening. For example, if engine stops working, so it is a loss of primary function. It will come as a severity 8. The severity 7 is a degradation of primary function. It means vehicle is operable but at reduced level of performance. For example, vehicle is running but not going beyond the speed of 20 or 30. It is a degradation of primary function. Now discuss with respect to the manufacturing or assembly effect. What is severity 8? Major disruption. It means 100% of product may have to be scrapped, line shut down or stop ship. Example, product goes to next operations, it is fitted there and after fitment the output came need to be scrapped. It means a part is fitted into the assembly and the part was defective and because of that 100% assembly may have to be scrapped. In that case severity 8 will be given. Line will be shut down in this case. It means because of the failure, complete line has to be shut down. So here the severity will be given as 8. Significant disruption severity 7. It means a portion of the production run may have to be scrapped. In severity 8, 100% product may have to be scrapped. In severity 7, a portion of the production run may have to be scrapped, not the 100%. Deviation from primary process including decreasing line speed or added manpower. At severity 8, line was shut down. Here the speed is decreased or manpower is added to run the line. Now severity 6 and 5. With respect to the customer effect, it is loss or degradation of secondary function. Secondary functions are the functions those gives comfort and convenience to end user. For example, AC. If AC is not working, then it is the loss of secondary functions. So severity will be given 6 here. Similarly, degradation of secondary function, vehicle operable but comfort and convenience functions are at reduced level of performance. Severity is 5. In this case, AC is working but not cooling effectively. This is severity 5. Here with respect to manufacturing and assembly effect, it is called moderate disruption. So here 100% of product run may have to be reworked offline and accepted. So here in this case, if the part is assembled, the assembly need to be reworked offline. Let's discuss severity 5. A portion of production run may have to be reworked offline and accepted. Here 100% production run has to be reworked. Here a portion of production run may have to be reworked. Let's discuss severity 4, 3, 2, 1. So with respect to the end user, the severity 4, 3 and 2 is coming in annoyance. Annoyance means something that irritates the customer but definitely no loss of primary and secondary function. So severity 4, appearance or audible noise. Vehicle operable item does not confirm or notice by most customer more than 75. It means something with respect to the appearance or audible noise. Some noise is coming into the vehicle and that noise is being noted by more than 75% customer. Then it is severity 4. Or anything which impact the appearance like some rust is coming on the parts and more than 75% customer can notice it. Then it is severity 4. Severity 3 is also same but now only 50% customer can notice it. It is severity 3. Severity 2, the statement is same but less than 25% customer can notice it. It is severity 2. Severity 1, no effect, no impact on the end user is severity 1. With respect to the assembly operation, severity 4 and severity 3 is called moderate disruption. So, here 100% of the product run may have to be reworked in station before it is processed. So, here also rework is being done, 100% rework is being done, but in station and before it is processed. It means before it is going to next operations or before it is going to end. Earlier, rework was being done but offline and accepted. So earlier rework was being done offline, so it was severity 6. Now rework is being done in station, it is severity 4. Now in station rework 100% is severity 4, and if a portion of production run may have to be reworked in station before it is processed, then it is severity 3. Severity 2, minor disruption, slight inconvenience to process, operation or operator. So here no loss of the productivity but some inconvenience to the operator is happening, that is severity 2. Severity 1, no impact on the process, that is severity 1. Now let's discuss the occurrence. Occurrence is based on the past data. Occurrence means how many times it has happened into the past. We have taken two parameters to give the occurrence rating. One is failure rate, the another one is process capability. Let's first discuss the occurrence rating 10. If the failure rate is 1 in 2, then occurrence rating will be 10. Or process capability is less than 0.33, then also occurrence rating will be 10. So either failure rate 1 in 2 or process capability less than 0.33 or both. In all three cases, occurrence rating will be 10. Now, if the failure rate is 1 in 3, slightly better, or process capability is above 0.33 but lesser than 0.51, then occurrence rating will be 9. Both 10 and 9 occurrence rating are considered as very high occurrence because failure is almost inevitable. Repeated failures are happening. Now let's discuss the occurrence rating 8 and 7. Every one failure in 8 or process capability above 0.51 but below 0.67 calls for occurrence rating 8. Now for occurrence rating 7, every one failure in 20 or process capability index above 0.67 but below 0.83 calls for occurrence rating 7. Here in occurrence rating 8 and 7, process is not in statical control or previously similar process have experienced some kind of problems. Let's discuss occurrence rating 6, 5 and 4. For occurrence rating 6, failure rate is 1 in 80, 1 in every 80 numbers, or process capability is higher than 0.83 but lower than 1 is occurrence rating 6. When failure is 1 in 400 or process capability is more than 1 but below 1.17, then occurrence rating is 5. Failure rate is 1 in 2000 and process capability more than 1.17 but lesser than 1.33, then occurrence rating is 4. These three ratings are called moderate rating. With these three rating, process is in statistical control, but there are some isolated failures also. Previously, similar processes have experienced occasional failure or out of control conditions. Now, let's discuss the occurrence rating 3 and 2. Occurrence rating 3. The failure rate is 1 in 15,000. Process capability is more than 1.33 and below 1.50. Occurrence rating 2. The failure rate is 1 in 150k and process capability is more than 1.50 and lesser than 1.67. These two ratings are called log occurrence. Process is in statistical control and there are some isolated failure associated with almost identical processes. For example, some failure happens in development time but not in production time. Will come here. Now let's discuss occurrence rating 1. Failure rate is very low, 1 in 1.5 million. And process capability is more than 1.67. Then occurrence rating is 1 at the lowest. Here as a process there is no chance of failure occurrence. There is no chance of occurrence, then we can say occurrence rating is 1. Detection rating 10. With respect to DFMEA, if you are not able to detect the failure either by virtual analysis like CAE or FEA or by validation, then it is a DFMEA detection rating 10. With respect to PFMEA, in the process you are not able to detect the failure by audible meaning, by attribute or by variable gauging. Now coming to detection rating 9, very remote, not likely to detect at any stage. Here weak detection capabilities, virtual analysis CAE or FEA is not correlated to actual operating condition. Virtual analysis is available but they are not correlated with actual operating condition. In the process not likely to detect at any stage, failure mode or error is not easily detected. It is being detected in some of the random audits. Now let's discuss the DFMEA detection rating 8, 7 and 6. 8, 7, 6 are the category where failure detection is being happen post design freeze or prior to launch, just before the product is reaching to the customer. For 876, the condition post design freeze and prior to launch is fixed. The difference is when the detection rating is 8, you are able to test whether product is passing or failing. It is just an attribute analysis about the product. When it comes to 7, you are doing test to failure. It means you are able to find out the life of the product also. Detection rating 6, you are able to find out degradation testing. You are able to find out performance degradations with time because of wear and tear, corrosion and other things. Coming to process part. Here failure mode detection post processing by operator through visual, tactical, audible meaning. after the part is being made, post processing, you are able to detect through visual, tactical or audible meaning. It means you need an inspector who is able to detect visually, tactically or by audible means. Here the skill of the inspectors play a vital role. When it comes to the rating 7, in station by operator through visual, tactical or audible means. Earlier it was post processing. Here when the rating comes 7, it is in station by the operator. Or post processing through attribute gauging. You are able to detect post processing but through a gauging, not by the skill of the operator but through a gauging, go no gauge, torque range, you are able to detect the failure. Coming to rating 6, failure mode detection post processing by operator through use of variable gauging. Variable gauging means when you are able to measure the variable data. It means if you are taking a dimension with vernier caliper, it is giving you variable data. So post processing by variable gauging or in station through attribute gauging gives a rating 6 for the detection. Rating 5, 4 and 3, detection rating for DFMEA, it is prior to design freeze. So earlier it was after the design freeze or prior to launch. For rating 5, 4 and 3, you are able to detect prior to design freeze. Test criteria for rating 5 corresponds to the test criteria of rating 8. The difference is for rating 5, test is happening prior to design freeze. Similar is the condition for rating 4. The test is test to failure, just it is happening prior to design freeze. Similar is the condition for rating 3 also. It is similar to rating 6, just happening prior to design freeze. Coming to the process, rating 5 means failure mode detection in station by operator through use of variable gauging. Here in station and variable gauging, or by automated control in station that will detect discrepant part and notify operator. So it will give some light or buzzer, or gauging performed on setup or first piece approval. So setup or first piece approval through gauging will be given as a rating 5. Failure mode detection post processing by automated control that will detect discrepant part and log the part to prevent further processing. So here automated control is there but post processing and it is preventing further processing. So the rating is 4. Failure mode detection in station by automated control that will detect discrepant part and log the part in station to prevent further processing. So earlier it was post processing detection by automated control and preventing further processing. When the detection rating is 3, it is in station detection by automated control and preventing further processing. Coming to 2, with respect to DFMEA, design analysis detection control have a strong detection capabilities. Virtual analysis CAE FEA is highly correlated to actual operating condition. It means you are virtually able to predict the failure. Your CAE and FEA are very highly correlated to actual operating condition. Then detection rating is 2. Error detection in station by automated control that will detect error and prevent the part from being made. Here it will prevent the part from being made. Earlier prevent further processing. It meant it was being produced. It will prevent the part from being made as a wrong part or as a failure. It is detection rating 2. Detection rating 1, it means failure cause or failure mode cannot occur. It is fully prevented through design solution. It means failure cannot happen. You have given some design pokayoke or some proven design standard are available. So it is like that, failure cannot happen at all. Some design pokayoke is there. Error prevention, here also it is same. Because of some error prevention as a result of fixture design, machine design or part design, process pokayoke is here to prevent the error. That is a detection rating 1. Let's understand FMEA with a simple example. The green color area you see here is the title block of FMEA format. It contains important information such as part number, part name, revision number, supplier name, core team member, document number, FMEA initiation date, latest revision number and date. Now moving to main sheet. The first column lists the process step and operation number. The second column captures the requirement for the operation such as surface roughness value for milling. The third column is for the potential failure mode. What can go wrong during the process? The fourth column describes the effect of that failure mode, for which we will later assign a severity ranking. The fifth column is the severity ranking itself. The sixth column is for criticality class. If any critical characteristics are associated with the process, they must be mentioned here. The seventh column captures the potential cause of the failure. The eighth and ninth column focus on occurrence. They include the current control measure for prevention and the occurrence rating. The 10th and 11th column are for detection, including the current detection control and their detection rating. The next column calculates the risk priority number RPN followed by action priority AP. The subsequent columns are related to action plan for risk mitigation. Let's take this example of operation 50 machining setup 1. So the process step is operation 50 and the name of the operation is machining setup 1. The requirement of the operation is dowel hole size should be dia 8H7. The potential failure mode is double hole undersize. The potential effect of this failure mode will be analyzed at 4 customer point. These 4 customer point are, first is NP, that is the next process. So after operation 50, the next process will be operation 60. So the effect of the potential failure will be analyzed on next process is NP. SP is subsequent process. These are the operation after operation 60. CE is customer end. If take the case this part is being supplied to OEM, where OEM is assembling this part. So the customer end is the OEM's assembly line. EU is end user. So end user who is going to use the final product is the end user. Based on the severity ranking table, severity is given at each and every customer end and the higher severity is 8. So we will take 8 for the calculation. Here in this column potential causes for the failure is given. With respect to these potential causes, control prevention is given in this column and based on this occurrence rating is given here. In this column current detection system is given and based on this current detection control detection rating is given here. So we will take higher one, so 8, 5 and 5. When we multiply this, it comes an RPN number of 200. As we calculated the RPN number, we will find out the action priority with the help of this table. For 8 severity rating which is here, 5 occurrence rating which is here and 5 detection rating which is here. So the risk came as medium risk. Since the risk is medium, the organization decided to take corrective action. So 2 action has been taken by the organization to improve the occurrence rating and detection rating. After implementing these 2 actions, occurrence rating goes down to 3 and detection rating goes down to 3 all. And the RPN number become 72 and the risk become the low risk. In this way, the FMEA process must be carried out systematically for each process step by the team. I hope this example helped you understand the concept and practical approach to FMEA. Please share your valuable feedback in the comments and don't forget to subscribe to my channel Quality Talks. Stay connected. Thank you very much.